Okay, so I said I hope everyone had a good lunch. What I'm going to do now is cover accessing software, and this will cover sort of two sort of basic areas. One is some sense explain how software is found in a Unix environment. When you type a command, how does it know where to find it, and which one does it pick up if there's multiple versions? And then we'll talk about how we use something called modules on a centrally installed system like Archer to manage that and make it work for us rather than work against us. So so it's often the case on HPC systems that not much software is loaded by default. You might want to load it yourself. This is very different from what you get on a desktop machine. You know, if you have a modern version of Ubuntu or Mac or Windows 10, you can expect a fairly base level of consistent software across any machine that has those operating systems. HPC systems tend to be a bit more bespoke, and so typically, you don't really know what kind of versions of software, what software you're going to get and what versions there are. So often a technique is not to load a version of a software, not to make it available at all, so people have to explicitly choose it so they get the right version. And so, I mean, the reason why we have to do this is that there's really one of the biggest headaches in modern programming, modern computing, is software incompatibility. Okay, so often, as it says here, the presence or absence of a software package will break others that depend on it, because modern software, almost nobody now writes a program which is completely standalone. Even if you think you've written a standalone C program, you need a C compiler to compile it. And what version of C compiler are you using? You think you've written a standalone Python program, but what version of Python are you using to run it? So it's very, very rare now that software doesn't depend on other software. And so there was a classic version here that Python 3 had a command that when you ran it against Python 2, that you got some nasty glibx cx3 for not found error. A completely meaningless error. So, I mean, this is different from software versioning, though. Software versioning is another common issue. You might have a software which evolves over time, and for some reason you might want to use the most recent version, or you might want to use the old version, or you might want to check that there's been updates to the software, a simulation package like GROMACS. You want to check your results for the new version are same as the results for the old version before you move to the new version. There are two concepts here. One is that software depends on other pieces of software. They have to be compatible, but also that any particular piece of software will have multiple versions you want installed at the same time. So, for example, VASP, which is a materials modeling package, might depend on a fast Fourier transform library. You have to know which version you are. And so the way this is done is through modules. You probably won't have modules loaded on your desktop machine, even if it's even if you're using a Linux system, but it is commonly used on large systems. And actually, someone mentioned this yesterday, and I wasn't aware of it, but they're built there are two systems, the TCL modules and LMOD. And someone mentioned LMOD yesterday. I think that we're using the TCL system here, but the way it works is the same. Okay. What you do is you use the module command to load various pieces of software, and then and so you can you use the module command. You can module load, module unload, and do various tasks. So what's worth doing is I'll maybe go onto Archer, share my window. It's easier to see with a particular example. So I'll start sharing the right screen now. Now, if you look at the notes, there's a slight incompatibility. It says that often you have no modules loaded. Although Archer is a kind of a bespoke system, it is a Cray, and Cray are quite big on having fairly standard instances. So when you log into Archer, if you look at the modules which are loaded, which you do with module list, I've got caps lock on stupidly, module list, you'll see there are a lot of modules loaded. On a lot of other systems, if you run our Cirrus system, you'd see very much fewer modules loaded. But there is a default set of modules loaded. Okay. And that tells you we'll come back to what that means at the moment. But this shows you, for example, that anything that looks, well, the PBS version is version 13.04. We have a particular version of PBS loaded, or a particular version of Nano loaded, okay, and a particular version of something else loaded. Anything that looks interesting here, or the MPI library, for example. And so, well, that's what's loaded, but how do you know what the possibilities are? Well, module avail does that, tells you what modules are available. And actually, there's a huge number of them. So there's on the Cray, there are, now, according to that, I wanted to word count the list, and I got 0. That's because module, I think we mentioned this before, module avail very annoying in that it outputs to standard error. So we have to do that. Well, what I have to do is a magic syntax, which says, this strange syntax says, send stream 2, which is the error output, to the same stream as stream 1. But it means everything appears on the screen. Anyway, but there are almost 900 modules available on Archer because it's been around for 6 or 7 years, okay? But the main thing you want to do is how to load software. So when you log on to Archer, for example, you don't have any Python available. If I type Python 3, it says, I'll maybe clear the screen first. I type Python 3, and it says, command not found. There's no Python 3, okay? Python 3 is not, so what do I know? Well, which is a useful command. Which tells you which version you're running. And what it says is, there's no Python 3 in any of these, which no Python 3. So clearly, this is where Archer is looking for. So clearly, it's going through all these directories, of which there are dozens and dozens and dozens, of looking for Python 3 and not finding it. Okay. So which is actually a very useful command. It tells you which version is actually being run. Okay. So the way on Archer we load up Python is with module load. So we do module load, and it turns out that on Archer, the Python is available under a package called Anaconda. So you have to load module load Anaconda /Python 3. Okay. Now if I type which Python 3, it says it's loaded it. Okay, it's found it there. Okay, so it's found it there. It's running /home for Y07, so it says Python 3. Okay, so that's what it's done. What happened? Well, all it's done is that Unix has a concept for a search path. So there's a variable called path, which is set in your shell, in the bash shell, which is the search directory. Okay, so this you'll see is a huge list, which is exactly the same as what we got with the first which command. So if I did which Python 3, yeah, it looked at EPCC Archer tools. Then when I did module load Python, it put in a search path at the start to my path. Home Y07. So basically the path is a colon separated list of directories which are searched in order until a match is found, and the first one which is found is used. So if you were designing a modern operating system, not one written in the 70s, you wouldn't do this. You'd have a much more sophisticated, but in Unix, the entirety of the search path is one string, one horrible, bloated, massive string separated by colons, almost impossible to manage by hand, okay? And so what modules do is they actually fundamentally just manipulate your path and other search paths as well. But they do it in a consistent, and you could just go and edit this path, but it would just rapidly become a nightmare. And so the important point is that the module the module load manipulates your path to make sure that the paths which pick up the software are at the front and are therefore picked up first. Okay, so actually it's finding it from there. Let's list that. And we'll see that in there's actually a lot of stuff, one of which is Python. I'm scrolling up here. There's actually an awful lot of stuff. So this loaded a lot of stuff, including Jupyter. Where's the Python? There's Python 3, Python 3.5, Python 3.5M, yeah, all kinds of stuff. But so all that happens is installed in various locations on Archer are pieces of software And which ones you find depend on your search path. And you have complete control over your path, but it's much more useful to manipulate it using the modules rather than by hand. Okay, so that's very, very useful. So, module load adds software to your path. It does other things as well. We'll look at that basically again. But for example, if I now do module list, you'll see that at the end is the Anaconda Python 3. I could unload it. I could do module unload Anaconda / Python 3. And now if I do module list, it's gone. Okay, so if I now type Python 3, it's not there. Okay, and so the example in the notes is to load a package called abinit, which is I think it's some molecular dynamics package. I don't quite know what it does, but it open source materials science modeling software package. If I module load abinit, you'll see if I do module list that it's loaded a particular version. But I just asked it to module load abinit, but it's loaded a particular version, 7.1.0.4. It'd be nice to know, are there any other versions available? So if I do module avail abinit, what's available, you'll see that there's actually 3 available. 7.10.4, which is the default, and 2 newer ones, 8.4.2 and 8.10.1. So I could just load, I can do a particular, there will be a default version, but I can select a particular version by module load abinit / 8.44.2. Now actually, module load, sorry. Okay. Now you actually see I have both modules loaded. So that module should really have complained, okay? It should really have complained that there wasn't, so that module, these modules, that one wasn't probably particularly well configured. So I have to module on, so this is getting a bit, maybe the Python one would be avail. If I do module avail Anaconda, you'll see that I have a lot of versions here, Anaconda, Python 2. So let's load, we'll load Anaconda / Python 3, which we did before. Do module list. We've got it there at the bottom. Now I want to load a different one. Let's do module load a more version. So the one I loaded was the default, which is, where is it? Yeah, there's Anaconda Python 3. If I loaded, for example, a different one, there's a different one there. It says module Anaconda 2.9.3 conflicts with module. So it's saying you can't have them both loaded at once. So I can either load or unload, or I can do a module switch. Anaconda Python 3, sorry, Anaconda / Python 3 with the new one. And if I now do which Python 3, it should now appear from that new path. Yeah, it appeared from that new path. So the way that that modules work is it allows you to look at what modules are available and load and unload particular versions. And if the module has been well written, it will warn you about conflicts, and also it will load other dependencies. So if that package depended on other things, it would have done a kind of recursive load and sorted everything out, or complained if there are any conflicts. So modules are much more user friendly and flexible and easy to use than doing things by hand. If I do module list again, got all that stuff. Module purge deletes all the modules. It's not really a good thing to do in Archer because there are a lot of default modules you want. So if I now do module list, I have nothing. So, excuse me. Sorry. Oh, sorry about that. I was too late to get to the. So someone's raised their hand. Who was that? I didn't see. Sorry, I put the hand down before I saw who it was. Apologies. Someone raised their hand, but I didn't. Oh, bless you. Thanks. Okay. Thanks. Sorry. Yeah, I don't know where that that sneeze came from. So what I'm going to do is I'm actually going to log out and back in again to get the modules loaded again. That'll be the easiest thing to do. So I'll just, if I can find the right window, I log out and SSH back in. Okay. So we can look in detail at the GCC module. GCC is the GNU version of the C compiler. So this is a useful one because some software depends on what version of GCC you have loaded, and it's not just the compiler. There's a whole bunch of libraries as well. So you may not think that you're just like the Python example previously, you may not think that your program depends on the GCC library, but it may depend implicitly on some libraries. So if we look at module avail GCC, you'll see that we have quite a few versions available. And this is typical. We'll have some old versions. We'll have a default version, which is relatively new, and a couple of new versions. So when new software is released, it's typically put on as an availability, so you can use it, but it's not switched to the default. And then sometime in the future, there will be a system note to say, look, we're going to upgrade the default. So if I do module load GCC, we expect to load this version, and GCC, I can now get it to tell me what the version is, and we see it's 6.3 as we expected. Okay. If we try and load the new module, the newest one, for example, we get that conflict error. So we can either switch or swap. I think they're just synonyms for each other. Switch the GCC module with the new one, and now if I do GCC minus version, I'll see that I'm running on the 7.3, the most recent one. So that's all worked. That's all worked reasonably nicely. The module switch is exactly the same as doing an unload then a load. Okay. Module swap, module swip are just the same as before. Okay. So the important thing is that when you log in when you submit a batch script, you just get the default environment. So it's important that if you use non-default software, which you inevitably will do in your programs, you need to do it in your batch scripts. And that's why if we look at the, I think it was in the, I have a PBS example here where I'm running the Sharpen example. If I look at the Sharpen example job, okay, no, that was the wrong. I must have just called it Sharpen then. Run sharpen.pbs. What we did is we loaded EPCC training /Sharpen. Okay. Now, this is just like a dummy. I've put my Sharpen example, it's a very, very simple parallel program, into a module just to show you how it works. But we load, and then not only does it set not only does it set your path, it also sets some magic variables. And so Sharpen data is where you got the input file, and that was also set by the module. So if I do echo$sharpen data, you'll see it has no value. And if I do which sharpen, there's no sharpen there. Okay. If I now clear that and do module load EPCC training, and you can do completion on these things again, a Sharpen. If I do, that's now set to the location, and I can list that, and that's where it is. And if I do which Sharpen, if I do module avail EPCC training, you will see that there's actually another thing there, but this is the EPCC training Sharpen one. But there's currently only one version, but in the future I could upgrade and make a default version, which was a different version from the current one. So loading modules can have side effects of setting other environment variables. So if I echo.path now, you will see that path for the Sharpen example is now uppermost in my path. Okay, and the way that it's a bit confusing because there are multiple versions. It will just pick the first one it finds. So which is always, I said, which is always your friend. Okay. So a classic example, this is a classic bug that people have. It's a very common error. Okay. I want to have a shell script that's called test. Okay. Okay. Let's make it executable and let's run it. Okay. So let's do that again. Cat test. Yeah. I run it and I get nothing. What do you think's happened there? So I've written a program called test. I run it. I try and run it, and I get no output at all. Although all it's supposed to be doing is echoing a. Can anyone think what's happened, or how I could find out what's going on? Where has it picked up the test program from? Do I know where it's picked it up from? Well, no. If I do echo dot, so it's a good. Yes, if I do echo path, you will see that dot is way down at the end. Okay, so it looks all the way through here before it looks in the current directory. So there must be a program called test somewhere in there. Okay, how can I find out where it's finding it from? It wasn't actually, well, maybe from a module, but it's in the path basically. So there's a program called test in the path, and because dot is right at the end, it's picking up the other one first. So how can I find out which one I'm actually running? We used it before. Actually, the clue's in the, yes. If I do which test, actually use a bit. It's actually a built-in function. Man test is a function to check. It's a way to compare, if two expressions are or not. So how can I actually run the test program? The one I've written here. If I write test, yeah, /test. So in fact, you will see that fairly obsessively I put // in the front of everything because it's very, very easy to get caught out by this. Yeah. So I think it's a very, very, so Unix, again, is 50 years old or more. This is not a sensible way of managing software. It's insanity, yeah, to say we will have a single character string separated by colons, which is traversed from left to right, and the first one we find is picked up. That is not how you would do it if you design an operating system today. But, it's too late to change. So I obsessively do /. In fact, now if we copy test to Wibble, I type Wibble, it runs it because dot is in the path. Okay, but if I did export path equals, and let's set my path to be the whole thing but without the dot. Okay, so I've just copied everything here. It's a very dangerous thing to do. Okay, if I now type Wibble, it's not there because dot isn't in the path. Okay, so that forces me to do /Wibble. So I actually don't like having dot in the path, because if you don't have dot in the, I think you shouldn't have dot in the path, because it means it forces you to always write // for your own programs, and that means if there does happen to be another one with the same name, there's no ambiguity. If you have dot in the path, you get the habit of just writing my program, and then you have this danger it might run another one. It's a very, very dangerous, potentially dangerous bug actually. So yeah, so it's not a particularly, you can see that doing this by hand is really, yeah, but how do I know it's unique? How do I know there's not a program called, so for example, so there's 199 programs beginning with X. There are, yeah, so you know, if you do autocomplete, hit a character like A and hit tab, it'll complete to all the possibilities. There's 142 programs beginning with A. Okay, so there's actually quite a lot of. If I hit tab, no, it doesn't bother. Yes, there are 4,372 programs in my search path. Okay, if I hit tab, it will say, do you realize this? So you're right, you can try and call your program something unique, but the problem is test is test is the one that you often call your program. So that's what you should do. But I think that, you know, I would rather not have dot in the path, and I'm surprised. I think bizarrely there's a module called dot, and if so, let's basically log in again. Okay. Let's go back to where we were. It was in Sharpen, wasn't it? If I do test, now if I do wibble, but there is actually a row. Oh no, it doesn't work. Okay, fine. I was wrong. That was not true. So some systems there's a module called dot which puts dots in your path, but that's not true here. But anyway, so you know, other than that, but modules are the way to go. You should really never just play around with your path by hand, because it will screw you up. Now, what is useful to know is if every time you log on you want to have the GCC 7.3 module, you don't want to have to type it every time you log in. Okay, so there are ways of automating this. So if I actually go back to the whenever you log in a shell, your bash script runs a couple of setup programs, bash RC and bash profile. And so there's a subtle difference between bash R3 and bash profile as to when they're run. But if I go to my home directory, you'll see, whoops, .b star, you'll see that there's a bash history and a bash RC, and I can emax .bash RC, and whoops, that was the wrong one. And you'll see what it does is it sets up, there's a lot of stuff in there, but nothing, a lot of comments. I don't know what that's doing, but what I could do is I could do module load GCC slash oh, sorry, that's good. I've switched around. Well spotted. Apologies for that. So what I will do is I'll quit this. So what I did is I logged in and went to my home directory. I listed something with .b, so we have a .bash RC, and if I edit that, you'll see it's full of fairly cryptic stuff, most of which is commented out. Yeah, this is some, but what I could do here is I could do module load GCC slash 7.3.0. Okay, whoops, 7.3.0. So in fact, yeah. So if I do which GCC, it's user bin GCC, which isn't the one I want. It's actually a very, very old version. But if I now log out and back in again, you'll see if I now type which GCC, it's loaded that one. So if you have modules which you load all the time, you should put them in your .bash RC. I think it stands for bash resource configuration, I think. So that's a good thing to do. I would definitely put module loads explicitly into all your PBS scripts, because then if you give it to a colleague, they can see, you know, exactly what you need to load. Relying on default settings is always a bit dangerous. So it is a bit of a balancing act. The obvious question is this run, yeah, in the PBS? So the final thing I want to talk about now is installing software of your own. And there's a couple of comments I wanted to make. So often, I mean, depending on what you're doing, you may be lucky enough that you have everything installed, but every now and again, you're going to install some software. And so this is a random piece of software we're using for this example. There's a bioinformatics tool called TK, okay? So we need to obtain the source code from Git. So this is just a map. Now you need to get. We'll look in the next lecture about how to transfer files, but we're going to use Git. So if I type git clone, I will now switch back to my terminal. If I type git clone, it worked. So there have been cases due to various technicalities to do with certificates and such like. I put in a module switch there. There's slight technicality there, but okay, I've been able to clone it. That's good, and you can see I've got the software, and then I will. What do I have to do now? Oh, it was into secure. Okay. There's a README file. Oh, it wasn't called that. What's it called? TK. There's a README file which tells me how to and it says you should just type make. So I just type make, and it compiles it, and now I can just run the program, and it says this is Secret version 1.3.5. You need to run it, and so I've compiled and run a program. So you can compile and run your programs. However, you need to be careful, because this is if you Google how to install software and you find something on Stack Overflow or on the internet, they will almost always assume you want to install it on your laptop. Okay, so they will almost always tell you to do something like, if you can see, they will almost always tell you to do something like sudo. Okay, so if you Google how to do anything on Unix or Ubuntu, for example, the classic release, you look at the examples that almost always tell you to install software and such like. They'll ask you to do sudo then command. Does anyone know what sudo does? So sorry, that's not having the wrong window. Yes, super. So I think it stands for substitute user actually, but sudo on its own runs as the super user. Okay, so it says I want you to install this software as root, as admin. Now, of course, if you're doing that on your own laptop, you probably have root access on your laptop, okay, or admin privileges on a Windows system, but you do not have super user or root access on something like Archer. And if you type sudo, it will probably raise a security exception, because the systems people will intercept that command and think that you are trying to subvert the system. So this is a constant thorn in our sides on Archer, but especially with students and such like who are a bit more green around, well, maybe they're used to typing this, they'll often try and do this and it won't work, and the systems people get upset. They'll say there's somebody trying to gain root privileges when they don't have it. So that is just a word of warning that, you know, the base assumption now when people talk about installing software is that you have root or admin privileges. 20 years ago, that would have been unthinkable. Now, 20 years ago, people used centralized systems where there were a few sysadmins who knew the root password. Now we've all gone to our own laptops. We tend to know the root or admin password. So we're used to doing things as root or admin, as super user. But so you should avoid doing that. And that's a classic mistake. So I didn't hit return there. I hit Control C. If I'd hit return, well, it would have done something funny actually, but there you go. So that's the only sort of caveat I would say about installing software, is that it's perfectly okay to install programs in your own directory. There's no problem with that, but be careful that you or that the installation scripts don't rely on being admin. Or for example, they will probably try and install by default in some central location which is available to everybody, but that central location will have, so if I actually do ls -l on slash, you'll see that right at the top level of the Unix hierarchy, all the files are owned by root, who is the super user. Okay, nobody else is allowed to touch them. And if you want to install software centrally, you generally need to have root privileges. So again, you do need to be careful when you install software. At best, it just won't work. At worst, you might get a nasty email from somebody saying that you were checking that you weren't trying to subvert privileges. So, okay. So what I wanted to do just before the break was to do the file transfer. So I'll switch to the actual page. And so the keys are you load software with module load software name, you unload it with module purge, module avail tells you what's available, and it's useful to know that module avail, you can do module avail GCC, module avail VASP. It will tell you what versions of VASP or GCC are available, and that module system handles software versioning and conflicts for you, which is very, very useful. If you do want to load various software packages by default, you can edit your bash RC. So I'll go through this relatively quickly, but how do I upload or download files to cluster? How do we do it? So this is often a bit of a headache, in that computing with a remote computer isn't any use if you can't get files on or off. And there are several ways of doing it, from command line options to GUIs. There is a GUI mentioned here called FileZilla, which I'm not going to cover for want of time, although you can install it if you want. But the interesting thing about MOBA Xterm is that not only does it include an SSH client, a local bash program, and all the infrastructure for doing Unix graphics, all by default, it also has a drag and drop file transfer client. So you can actually you can copy files to and from Archer using MOBA Xterm just by drag and drop. I wouldn't recommend that for very big files, but you know, it is worth doing. So I'm just going to go through the various options you have for copying data to and from Archer. So rather than follow them, I'll show you my screen so you can follow it more easily. So you should see my screen. Okay, so first thing is called Wget. Okay, Wget is used for getting used for grabbing files off the internet from an HTTP server. Okay, so if there's a file stored on a web page, you can use Wget it to get. So for example, the bash lessons are stored here. Sorry, I've just done something stupid. Okay, I'm sorry. They're stored in that file, okay, but I need to Wget them. So what that says is, so if I went to this location with my browser, it would ask if I want to download them. But the problem about pointing your browser at a file is if you download it, it downloads it to your laptop, which is no use. You want to get it onto the onto Archer. So one way is if the file is on the web, you can pull it. So wget is saying, look, could you grab this file and stick it on my account? And then there it goes. Okay, so if I do ls minus lrt, there is it's got this bash lesson file. Okay, the reason it's given it a .1 is I think I already had a conflict there. So actually you'll see, okay. No, yeah, so, okay. I already had a bash lesson from yesterday, so actually let's remove them. And then the wget will do what we expect, which is create it with the right name, which is bash lesson. I'm confused. Okay. Maybe I'm going to get this right at one point. So wget tries to be clever, and if there's a conflict with the name, it calls it something with a .1 on the end, which I find a bit annoying, but that seems to be the modern way of things. There was a question here. Yes, exactly. I didn't delete to get you right, so I spotted that in the end. But yeah, you were quicker to the ball with me. I didn't delete to get rid of the one. And I think putting the .1 on the end is a bit cheesy, but anyway, that's what it does. So that's a way of pulling a file onto Archer from the web. So that can be useful. However, actually, often you want to push files. So it's useful to push files onto Archer. So what I will do is I will, to do this, I'm probably going to have to have two windows. So what can I do? I don't usually use new tabs, but let's do a different tab. Okay, so now I have tab. This is on my local file. Okay, so I'm in home DSH and if I list, then I've got a copy of a PDF copy of an MPI book, which was available for free during lockdown from Wiley, which is quite nice of them. If I wanted that PDF file onto Archer, if I wanted to copy it locally, I could do copy MPI book.pdf to documents, for example. Okay. And then now in documents, there is going to be the MPI book.pdf. This is all local, okay? This is all on my local laptop, okay? Okay. Now let's, on Archer, create a directory called documents. Okay, that's now empty. But SCP is a very, very powerful command. Copy copies that file to that directory locally. SCP, okay, I just do tc011 at co. So copy just does a local copy. SCP, you specify the destination folder, the destination machine in the normal way you would with SSH, and anything afterwards is the file name. So that just says copy the MPI book to tc011 login to Archer to documents. And it will ask me for my password, and because I specified the wrong username, apologies, it's tc011dsh, my username at Arch. So now it asks me for a password. It copies it, and if I go back to Archer, I can now see that it's appeared. Okay, so that's that there. And you can do it the other way around, of course. If I was, let's go to cd temp. I have a temporary directory. Do I have an MPI book here? I don't, but I can redo the copy. So instead of so that's saying copy from this location to local, and again, it will ask me for the password. Now, yeah. I think I got wrong there. No, I got it right, and now it's copied it locally to empty my book. Okay, so you know that is a very useful. SCP is a very useful way of copying files around, and the nice thing about it is it's very similar to CP, except you do S for SSH copy, and then you basically specify the target machine and user as username at target machine : and then it just works. So that's actually quite useful to do that. There is another way of doing this, and all the usual flags apply, so you can cursively, all kinds of stuff like that. There is another way of doing things called rsync. SCP can be quite limiting because, of course, it just allows you to copy. It isn't selective. You have to say what you want to copy, and typically you will copy too many things, okay? Because you will if you want to copy a whole directory from A to B, you get some new results, you copy it across, you'll copy all the new results and the files that hadn't changed. And so there's a piece of software called rsync, which I'll switch back to talk about, which has become more popular recently, which actually sort of, rather than just doing a copy, it synchronizes. And what it will do is it will check whether files have changed or not. And that allows you to do much more efficient copying, because it will only copy files or even portions of files that have changed. Okay, so rsync provides a much more advanced way for transferring files. It's typically faster than SCP and SFTP, which is the thing below, because it's much more clever, and it will look at what you have locally, what you have remotely, and only copy things that have changed. Okay, and so you know there is a this is the syntax here. Yeah, so rsync basically copies from one place to another, but it compares the two and will only upload those files that have changed. You do need to be careful because you know there's lots of options to it. You know, if you delete a file locally and then do an rsync, does it delete the file locally, remotely, and all things like this? But a lot of people do use rsync. I only use rsync. I use rsync on my laptop for backing up to a remote server, having all my data available on a remote server. I don't tend to use it for file transfer. I would prefer to use SCP, but some people do prefer to use rsync. So I'm not going to cover the use of rsync here, but it's available, and you do need to be. I would always do a quick test, because it is slightly scary, you know, which you need to be very clear, you know, what's going from A to B, what is being copied, what isn't being copied, and whether things which don't exist are being deleted. The name is slightly weird. rsync doesn't really do it. You would think that after an rsync, the two copies would be the same. That's not true. rsync doesn't necessarily do that. So you do need to be careful, but it can be useful. FileZilla is a GUI interface, drag and drop, which is available for, I believe, for Mac, Linux, and for Windows. And you know, you can download that if you want and use it. I haven't used it myself, but it's kind of a drag and drop kind of thing. One of the nice things about using a command line interface for copying files like SCP is that you can stick it in a bash script. So you know, you can run a bash script which runs a simulation program, post-processes the result, and then copies the result somewhere else. All of those can be done on the command line, but the good thing about a command line command is it's trivial to put it into a script. So that actually, you know, that's why I think I find GUI interfaces for file transfer slightly awkward in an HPC context. They're very easy to use on a one-off, but they don't integrate into workflows which use bash scripts. So that's probably one of my prejudices against them. One of the things you have to be aware of, though, is that when you copy data, it may take a long time, and actually, it's large numbers of files. Okay, actually, if you copy large numbers of files, individually it can take a long time, and it's very, very simple it's a very, very simple analogy. If I had to deliver 20 pints of milk to my friend on the other side of Edinburgh, I wouldn't grab 1 pint of milk, get in the car, drive over, give it to them, come back, grab another pint of milk, drive over. I would do them all at once. I would put all the pints of milk into one crate, stick them in my car and drive them over, because the overhead of doing each one individually is just way too much. And actually, often especially because modern internet bandwidths are so high, often the limit to transferring a small file has got nothing to do with the data. It's just the overhead of setting up the connection, initializing, all that stuff. And so one of the biggest mistakes people make is that they copy huge numbers of small files and they get an incredibly low bandwidth. It takes forever. The thing to do is to batch them up. And we've already seen tar as a way of unpacking data. Often by far the best thing to do before you transfer data is to tar it up, okay? Create a single directory, a single file, copy it and untar it at the other end. And that has a huge number of benefits, but really speed is really, it can make an enormous difference to copying data. So if your data copy is taking a long time, and you have lots and lots of little files, it's much quicker to pack them up into a bundle at one end, copy it and unpack it at the other end. And again, that bundling up can be put into your script, okay? So the tar command is kind of, it's quite useful, but standard thing to do is locally you create the data file, you can unpack it like this, and then you can copy it, okay? One mistake some people do make is they compress everything. Compression can be very useful. Text files compress very well, but binary data doesn't compress very well. So you do need to be careful. If you compressed a binary file, probably it's going to take longer to transfer than if you didn't compress it, because you'll spend ages and ages churning away for CPU to try and compress a file, reduce its size by a few percent, and you haven't gained anything. So yes, you should compress text files, but compressing data files raw data files isn't always the best thing to do, okay? There's one final thing, which is one of the killers, is that just like Fortran and C disagree about whether matrices are stored row major or column major, or whether arrays start at 1 or 0, Windows and Unix disagree about how to end a file. So on a Unix system, every line in a file ends with a new line. On a Windows system, every line in a file ends with a character return new line. And this can cause real problems. So most modern programming languages can handle this, but sometimes, if someone gives you an input file, which is a text file, you transfer it over, and if you get the most bizarre message you've ever seen as an error message, it can mean that what's happened is that you have got a file which is in the wrong format. And so I will just share. So there is so cat -a. So apparently, it's not how I would have done it. If I share my screen. So if I am on my local system here, if I create a file, okay, that contains, character on the end, that contains 26 characters, okay? So if I cat it, there it is. If I word count it, it's now it's 28 characters. Okay, so it clearly has 26 characters, and we talked about this yesterday. There are 2 extra characters, which are the character return and the end of file. Okay, that's why it's 28 characters long, not 26. If I want to convert that to a Unix, a DOS file, I do Unix to DOS test.txt. Okay, and it's not installed on my machine, so give me a second. This is me. This is my local machine. This is the usual. Apologies for this. I should have checked that this was installed locally before. Okay, so let's do it again. Cat test.txt, wc test.txt, ls-l test.txt. It's 28 characters long. If I do Unix to DOS, test.txt, converting, and if I do it again, you'll see it's now 30, because the end of line, there's a character return line feed rather than just a character return, and there must be something else at the end of file as well to add two characters to that. It's hard to tell sometimes if I think if you use VI, yes, if you use VI, you'll see these weird characters at the end. Yeah, that shows you, that Control M shows you that it's a DOS file. If I do Emacs, I think it's too clever. See, it just ignores Emacs just will. Emacs, if you look at the bottom here, knows it's a DOS file and just copes with it. But in the instructions, it says that you can do cat -a. So if I do cat test.txt, I couldn't tell the difference, but cat -a test.txt will show me the file at the end. So it just sometimes, you know, if things really go weird, it's worth checking if the text file you're using is in Unix or DOS format. So if you take text files from Windows to Unix, they end up having extra characters. If you take them from Linux to Windows, things can often appear not to have character returns in them, so it can be a bit of a nightmare. But that's just a bit of a final thing to be aware of. So I will now just conclude the lesson, and what we're going to do in the final session after the final break is we'll actually start running a parallel program on Archer. Sorry, I've lost my window, and we will look at the performance of it. It's hopefully quite fun. I'll explain what the Sharpen program actually does, and we will run it, and you can look at how much, what the benefits of parallelism are. Does my program actually go any faster, and if so, how much faster does it do? So just basically, Wget downloads a file from the internet, SCP transfers file. So if somebody says this file is on the internet, and you go to it with your browser and click download, it will download to your laptop. The best thing to do is just to cut and paste the URL and Wget it. And there are GUI clients like FileZilla, but actually, if you're a Windows user, I would probably recommend using Wget because I find that pretty good. Okay. So I know it's been a bit of a heavy day. There weren't many practicals in that session unless you were following along, but the next session is purely based around practicals, based around you running this program and looking at the performance and the speed up using QSub to run it on Archer. And so what I'll start with is just 5 or 10 minutes explaining what the Sharpen program is, how it works, and then we will just go through how to run it, and you'll actually see, you'll run a real program on tens, if you want hundreds of cores on Archer, and see it going faster, and look at how parallelism helps you in practice make a calculation go faster. So we're just about bang on time. We'll come back at 2:30, and that will aim to finish about 3:30, if that's okay. Time for questions at the end, but there was a question which I missed because I didn't scroll down to the bottom of the screen. Apologies. Matt asked, so is tar better than putting all the files you want in a directory, copying the whole directory? Yes, because if you copied the whole directory, it would still copy each file individually. So it depends, but if you have a large number of small files, then you should try and package them up. If you had 10 or 100 files, which are fairly big, it would be up to you. But if you have, often people have thousands and thousands of files, and in that case, rather than recursively copying the directory, which is still fundamentally copying each file individually, you want to create a single file, do a single copy, and unpack at the other end. Sorry, I missed your question, Matt. I didn't see it at the time. Is that okay? Yeah, cheers. What we're going to do is we're going to cover this sharpening example and use it as an exercise in running a real program on Archer. But I've lost my place. Fine. So this is where we were before. we're going to be using the Sharpen example. So I've extended this example slightly. It might take slightly more than this 20-25 minutes, but it was a question I think Matt asked before: how do I choose the correct resources for my jobs? How do I understand what resources my jobs are using? What you do is you test runs. You set up a test run and you run it, and then you kind of come up with, well, you know, this program works best on 100, 1,000 CPU cores. It's going to take a couple of hours. There's a bit of experimentation and playing around in advance. So I mean, basically, we now know everything we need to know about getting stuff onto and using the cluster. We can submit types of jobs and use pre-installed software, but how do we use the system effectively? So we need to understand the basics of benchmarking. So what you do with benchmarking is that you take a program and you run it in some limited, you cut it down in some way, and you run it in a way to investigate its performance. It gives you information on how well the computer is behaving, or how well your program is behaving. It gives you information on performance. You may find that on one system you should use 100 CPU cores, on another one you should use 1,000, depending on but benchmarking is a way of basically evaluating the performance of an application on a machine. Now, we're going to use an example which I wrote a long time ago called the Sharpen example. You'll see here that there's a to-do in there, which is a bit embarrassing, but unfortunately, with having to migrate this course at relatively short notice between different platforms, I wasn't able to put that in. So I have that information. It's not been integrated into this course. So I'm going to briefly go through, and I will put these slides up as PDFs for you. I'm just having a slight, there we go. So the image sharpening exercise, this comes from another course, but it's a standard example I use, and it's how to run a simple parallel program. And we've actually done that, but what we're going to do is we're going to investigate its performance. So I just want to very briefly outline how the program works, which will then give you some mental model for understanding how it performs when you run it on 1, 2, 4, 8, 16 and more CPU cores on Archer. So the aims of this are to familiarize yourself with running parallel programs. We've already done that, but we're going to look at it in a bit more detail. To run a real parallel code that does file I/O on different numbers of cores, measuring the time taken, and observe the increase in performance. There's a law called Amdahl's law, which describes a very basic description of how parallel programs perform. We won't have time to go into that today. This is an example I took from some people at Edinburgh. It's quite an old example, but I think it's quite useful. So the aim is to get you running on the machine. In a normal course, we do this quite early on to sort out all the practical details of usernames and passwords. You've done all that, so this isn't relevant for this. We've already done the logging in stage. So here's the image sharpening problem. So I'm going to tell you what the algorithm is in the implementation at a conceptual level, really. So image sharpening. Images can be fuzzy for two main reasons. One is random noise, okay, maybe low light conditions, or just not a very clear image, or you've done a very expanded image, or blurring because you've not basically not focused very well. This is a very famous picture of the Loch Ness Monster, which was taken, I think, in the 30s. It's clearly a fake. It was one of the most famous pictures of the Loch Ness Monster for a long time. It's been made blurry and fuzzy to make sure that you can't tell it's a fake, but there you go. What we're going to do is we want to improve the quality of an image by removing the noise and then sharpening up by detecting the edges. So what we want to do is we want to detect the edges. We want to find the edges in the image, and to make it less fuzzy, we want to enhance the edges to increase the definition. Unfortunately, we have to remove the noise before we do that, because if we have a noisy image, we won't be able to detect the edges. So what we do is we smooth to remove the noise. So we take each pixel and average it with all the pixels in some nearby neighborhood to smooth out random noise just by averaging. Then on that smoothed image, we detect the edges, and then we enhance the edges by multiplying them by some factor. So you take this is the example from the paper, but I have my own example. You take a fuzzy image, you detect the edges, which requires you to smooth it, and then you enhance the edges and you get a more sharpened image. You can see that the effect is actually more dramatic in the example I'm going to show. So the technicalities are you could ignore this if you want to, but I just wanted to give the mathematical detail. Each pixel is replaced by a weighted average of its neighbors. So you take each pixel and you take a region around the pixel, and you don't average each pixel with its neighbor, you weight it. So you include the nearby pixels with a high average and the faraway pixels with a lower average. So you average each pixel with its neighbors, but in some weighted way to give the nearer pixels more emphasis, okay? So that gives you a smoothed image because you've got rid of the noise. You then want to detect the edges, and the way we do the edge detection is we just take the second derivative, which in 2D is called the grad squared. So what we do is this is called the Laplacian operator, but basically we take the second derivative of the image. So if the image is flat, the pixel values are flat or changing linearly, there's no edge, but if they're changing in some rapid way, we call that an edge. And it turns out it's not obvious, but it's a bit of math to convince yourself that you can do that by if you average every pixel with all its nearby pixels using this strange weighting function, which has got both positive and negative values, you are simultaneously doing the smoothing and the edge detection. This is called a convolution operation. So that slide is just it, but that doesn't matter if that doesn't make any sense to you, because basically what you do is that for every pixel in the image, you loop over all the pixels in a large area surrounding it, and our area is going to be an 8 by 8 domain, i.e. a 17 by 17 square, and you add in the value of the pixel weighted by a filter, and this filter function combines the smoothing and the second derivative edge detection. So you define the edge view for every pixel ij. It's a 2D image, so you have ij coordinates. You loop over all the region plus or minus k plus or minus l, which is all the pixels in the d squared plus or minus d, and you take the image at that point times the filter value. So this is called a convolution operation. And the important point is it's a very expensive operation. This allows you to compute the edges, but it's quite a complicated operation. We then add the edges back into the original image to sharpen them up, and we then reconvert it back and scale it. But basically, you have to combine every pixel in the image with all the pixels in a 17 by 17 square, and that's almost, what, 300 or 400 pixels. So it's a very heavy operation to do. So that's what we want to do. How do we take advantage of parallel computing to do it? Well, if you think about it, each of these operations is independent. We can compute the edge value of every pixel independent from the other ones. And so we can divide the calculation up between different processors. And we do a very, very, very naive parallelization where we basically, each pixel could be processed independently. So a master process reads the image. It broadcasts the whole image to every process, just to make things simple. So every CPU, every processor has a copy of the entire image, but each process analyzes a subset of the pixels. And the way I do that is that we scan the image line by line, and with 4 processes, each processor computes every 4th pixel. So, you know, one processor would do pixels 0, 4, 8, and 12. The next one would do pixels 1, 5, 9, and 13. Then 2, 6, 10, and 14, and the final one would do pixels 3, 7, 12, and that doesn't work, 16. I got that wrong. Anyway, 3, 7, 11, and 15. Sorry. So there you're dividing the calculation up. So each CPU core, each processor is doing a subset of the calculation. Then you have to bring them all back together again, and then you save to disk. And the important point is that the program reports 2 times. The calculation time for just computing the edges on each process, and that's a parallel operation. So if we double the number of processors, we expect that the time to halve, because if we have 2 processors, each processor is working on half the image. If we have 4, they're each working on a quarter of the image. So we'd expect the performance to scale linearly with the number of processes. However, we have some I/O, which is reading the data in, distributing it, collecting it back, and then writing it out again. And that is done by a single processor. That's an overhead. So the way it works is we have a boss process who reads in the data from disk. The data is split up between all the processes, and then each process does a subset of the pixels in a round-robin fashion. So that's what it does. And so that's, you know, so the important point to realize is there are 2 components to the calculation. One is reading the data in, and the other is doing the calculation, and we report those times separately. What we actually do is we report the time for the total program, which includes everything, and the time just for the calculation. Okay. So that's a very brief overview of how the program works. I don't know if there's any questions for that. So I now go back to what we're going to do is so the kind of terminology people use, there's a kind of we often talk about an application. So the program we're running is the Sharpen program, which I've supplied you in a software module. We can call the application the combination of the program plus its data. Okay, that's a particular terminology. What we've seen before, though, to access the software and do input, the Sharpen program has been pre-installed on Archer. We saw that module load Sharpen, and then you need to copy the data across. So I'm just going to switch over to the I'm going to take a copy of that stuff there and switch over to my window and show you what I should be doing. Okay, so first of all, I need to go to the work directory, which is really important. cd/work /tco11 tco11 tco11 dsh. Okay, I'm gonna let's do create a directory benchmark. cd benchmark. Okay, so first of all, I want to module load EPCC training /Sharpen, and I need to copy the input file over, and that's now is current array in this file called Sharpen data /fuzzy.pgm. We've already seen this before. That didn't work. How have I done? Oh, dot. Sorry, I missed the dot. Okay, so now we have fuzzy.pgm, and as we saw before, we can look at that file, and I showed you what it looked like beforehand. But I now want to create, let's call it sharpen.pbs bin bash -l select. Let's run one process. Let's just run, it only runs for a few seconds, but let's say select 5 minutes. I've forgotten the syntax because I'm getting a bit apologies. Yes, it is. Sorry, it is -l. Sorry, I'm getting my and then #pbs -a tco11, and I'll call it. Let's give it a name. I'll call it benchmark. Okay. And then we have to do a number of things. We have to go to the right place. We want to load the module because we have to load it in the script. And now I just want to run, and by default, I just want to run on one process, ap run -n1./Sharpen. It's not ./Sharpen, Sharpen. Now we have already seen this, but let's just see if I can do this from scratch. Q sub -q, and I can't remember what the q is called. Sorry about this. I've lost my place in the notes. It's a bit poor. Okay. Let's see what's going on. Watch -n10 qstat -utco11 dsh. and it's queued. Should eventually run. They've been pretty slow today, but that's running eventually. So this is going to give us our baseline time for how this is. So we're running a serial program. We're running on one process. So let's, what do we get? So we've got no error, which is good. So the overall calculation time was 5.4097 seconds, but the runtime was this. So what this is telling you is that the calculation, this is just the pure calculation, took 5.4 seconds. The runtime was this. So the difference between this and this, I'm attributing to I/O. So I would say that this program ran for 5.6 seconds, of which 5.2 seconds was 5.4 seconds, sorry, was calculation. That's actually computing the pixels, and 0.2 seconds was an overhead. And what we're going to investigate in this example is what you would expect is if you increase the number of processes to larger numbers, okay, you'd expect the calculation time to reduce. If you had twice as many processes, you'd expect the calculation time to halve, roughly. But you'd expect this I/O overhead of 0.2 seconds to stay roughly constant, because that hasn't been parallelized. And that's why it was useful to go through the conceptual level of how the program actually works. So the exercise is to basically to go through and run the program on lots of different processes. And there is a couple of tables to fill in with runtimes. I have sample results, but now one thing which is useful is if you look at that output there, the program ran for 5 or 6 seconds, but according to the output, it started at 14:48:42 and ran to 48:51. So it actually ran for 9 seconds. So there's clearly some overhead to starting up the job. If you look in the notes, there is a way of finding out a bit more about what a job did, and it's called qstat -x -f, and then on the job number. Let's put it into less so we can see what's going on. So you can see that it has a lot of stuff going on, an awful lot of information, but actually the C time, I think, is when I submitted it, and I think this is when it actually runs, when it was queued. There's a lot of stuff in here, but you can see this is a historical record of what the job did. It has a lot of things about my variable list, which is useful, and it has things like my PBSO work in there, which is useful. And I think there's an actual, yeah, it was run on Archer 307. So that's just a useful way of this is actually very, very useful if you ever have any problems with the job, okay? If you think that there's sometimes occasionally we get nodes that go wrong, this allows you to see where I ran. I ran on a particular Archer node, which is listed down here somewhere, and that will allow me to identify, there we are, 3076, to identify it seems to be a problem. This is the kind of thing on the systems people do. If people think a job didn't work, they'll look at the log file and find out all the details about it and what it did. So the exercise is really to go through and run the example. We've viewed the image before. I showed you that in the last exercise, but to run it on lots of different numbers of processes and to fill in this table. Okay, so run your job script to run on multiple cores, okay, and complete a table like this. And what to do is you have the number of cores you run on. You can go up to maybe 96, which is a useful number. The overall runtime was reported in the script. Let's have a look at that again. So the first entry would be, there it is, overall runtime was 5.63 seconds. The calculation time was 5.41. The I/O time is the difference between the calculation time and the overall runtime. Okay, and that is about 0.2 seconds. And the total core seconds is the calculation time multiplied by the number of cores. That's basically the calculation time is how long that the CPU, I measured these internally in the program. The calculation time is how long the CPUs were active. But if you had 2 CPUs active for 3 seconds, that's actually 6 seconds of CPU time, because you have to multiply the number of CPUs. So that's a useful number to know. Okay, so I mean, I do have some sample results here, but it would be useful for you to maybe play around and do this benchmarking. One little hint, though, is that we can use some of our bash scripting skills here. And we could do something like, if I've got one node, yeah, I could request more. I could do for proc in 1, 2, 4, 6, 12, 24, do, done. So that's a very, these kind of techniques playing around. Oops, I've switched, not got the right window up, apologies. Yes, I do, sorry. So you can use, your bash scripting skills can be very useful here, especially for benchmarking. You can submit a single job. So there's the single PBS job, single script, but it runs the program multiple times on different numbers of processes. So AP run -n says run this program on this many processes. The more processors or CPU cores we use, the faster we'd expect it to execute. And rather than submitting lots and lots of jobs, we can do this. Or if we wanted to go up to more, we'd maybe have to go up to, if we wanted to go up to 48, we'd have to select 2 nodes, and we could stick a 48 on the end here. Not 49, but 48. So simple bash scripting is very, very useful in batch scripts to basically automate things and make your life easier. So what I thought it would be worth doing is basically let you have the next 10 or so minutes to maybe do some runs and fill in some of the tables, and then I'll come back and just review the results, and then give the final lecture, which is 10 or 15 minutes, just talking about being a good citizen. That is do's and don'ts, ways to make the best of your usage of Archer or any shared resource, things which may not have occurred to you when you're only using your laptop. But I think this is a useful example. It allows you to run a real program in parallel, but also to look at the performance. We can discuss, this is typical of the kind of performance this is a very simple program, but it's representative of the time of performance you get of a real program. So that's why I think it's useful to do. So as I said, unless there are any questions, I will basically leave the next, I guess, let's say 15 minutes till 3:10 for people can play around and actually run this program and look at the output they get, and then we can compare with my default answers and see what you know, whether there's any, whether we can understand the performance in terms of the way that the program actually works. So I will share the correct window now, which is basically this. You can do this example here, and if you have any problems, you can get a script which runs from the previous exercise, or the exercise a few episodes ago. You can get a script which runs the Sharpen program just on one process and update it to do a lot to be more interesting. So I saw there was a question. So the instructions say to load Sharpen, aren't we doing that in the script? Yes, but what I wanted you to do was I want you to copy over the fuzzy, I want you to get hold of the input data set, and normally that would be sitting there. When we ran it first a few episodes ago to make it completely self-contained and pre-packaged, I copied across the fuzzy, I copied over the input file in the script. That's not what you do in a real program. In a real program, you would have the input sitting there in your directory. You'd submit a program to operate on it. So the only reason you need to load the Sharpen is so you can get access to the input file to do that initial copy $sharpen data /fuzzy.pgm to dot. Once you've done that, you wouldn't have to load it again. Does that make sense? So I'm trying. Yeah, fine. That's a good question. So we saw before that you could view the output with using the display program. There might be some slight issues getting that working if you're using a Mac. I don't know. Did anyone manage to get the display working using? Yeah. Okay. So did it? So you're on a Mac. That's good. Did you have to install Xquartz? Is that how you did it, or did it? Okay, fine. You got Xquartz. Yeah. So there's a slight. Yeah. Sometimes you need to do more. As a Mac, even when you put Xquartz in, then sometimes Macs are still a bit sticky about access rights and such like, but it just seems to depend. So I was going to go through the results that I'd pre-prepared, but I didn't know if anyone had any other anyone had any comments. Anyone saw any performance characteristics they maybe did or didn't understand? I don't know if anyone managed to get any. Oh, okay. I think it's run now. I think it may have just run. Are you Pete? Oh, what's your username, Matt? Okay, so I think you've not submitted. I think you've submitted to the main queue. Let's have a look. Yeah, you've submitted the standard queue, so it will run, but it will take a while. So what you want to do is to queue sub. Just do it again. Do Q sub minus Q. So you submitted to the standard queue, which you're there basically in amongst all the other users, of whom there are hundreds, and it will run eventually, but it won't be given quite high priority. Yeah, sorry, right. So that was the yeah. So what I'll do is I'll just go through so I think you were probably doing. That's interesting. It must have been to do with the. Can you cut and paste your script into the chat if you don't mind? I saw you were running some jobs. We could do screen sharing, but it's a bit heavyweight for just looking at a text file. So okay, so this is the confusion about Archer, but the select is how many nodes you're requesting. So it's saying there you want to select 12. You're actually saying I want to select 12 nodes, which is actually 12 times 24 is can't do it. 288 cores. So to run on 12, you only need to select one node. Yeah, you get the reason it said is that I have only reserved 10 nodes for our exclusive use. When you do PBS myself select equals 12, you're asking for 12 nodes, but actually even on those 10 nodes you can run up to 240 processes. So that would have been rejected at submit time rather than at runtime. Yep. Okay. Fine. That's good. Yes. So that script would run normally, but be inefficient. You'd only be running on one of the 12 nodes. Yeah. Okay. Fine. I think. Were there any other quick questions before I? So what we wanted to do was fill in this this, and I ran a test example this morning, and what I saw was that the overall runtime gets quicker, which is good. Okay, So we start off at 5.7 seconds and we go down to under almost a quarter a second on 96 CPU cores, which is quite good. And from going from 1 to 2 CPU cores, the time almost halves, 5.66 seconds to 2.89. Okay. The other thing which is interesting is the I/O time is the difference between the overall runtime and the calculation time. And as we expected, that's roughly constant. So on one process, it takes 5.67 seconds to run, of which the time is 5.4 seconds running and 0.2 seconds I/O. You got to 96 cores, the calculation time is under a tenth of a second, but it still takes 0.23 seconds to run because there's still a tenth or 2/10 of a second I/O time. So the problem about this program is there's no point running on huge numbers of CPU cores because the amount of time is now dominated by the I/O, which is staying constant about between 0.1 and 0.2 seconds. Okay, so that correlates with how I explain the program works. The calculation time drops dramatically. The overall runtime doesn't because there's a fixed overhead of I/O, reading stuff in and writing stuff out. So are there any? So that does correlate with the kind of I/O time is always slightly, you share the I/O, you share the disk system with lots of other users, so the I/O time is always going to fluctuate, but here it's between 0.1 and 0.2 seconds, which comes to dominate the overall runtime on large numbers of cores. Okay, so that was that. Okay, to understand the performance, we want to get some, we're supposed to be scientists, we want to quantify things. Speed up is the ratio of the base runtime to the runtime of specified core count. So in other words, if you run a job on one process and it takes 10 seconds, and on two processes it takes 5, that's a speed up of 2, okay? It goes twice as fast. The ideal speed up is the ideal, that is the number of processes. If I ran on 10 processes, I'd hope the program would go 10 times faster. It won't for a number of reasons, but that's my ideal speed up. And the parallel efficiency is a measure of your speed up relative to the number of processes. So for example, if I ran on 10 processes and it went 6 times faster, okay, that would be 60% parallel efficiency. I run on 10 processes, I'd hope my program went 10 times faster, it actually went 6 times faster, so the parallel efficiency is 60%. So I stuck some of these figures here into this table here, and you'll see these are the same figures for the overall runtime. The ideal speed up is the number of cores. The actual speed up drops off. It's quite good for low numbers of cores, but it doesn't increase so much at high numbers of cores because the I/O starts to dominate, okay? So the parallel efficiency goes from the 90 or 80% through the 50s down to only 25. And that is because that is because the I/O starts to dominate. The most efficient use of resources, actually the most efficient use of resources is probably on one CPU core. Actually on Archer, the most efficient use of resources here is 24 CPU cores, because if you only run on one, you waste the other 23. Okay, so there is an overhead because parallel computing is never 100% efficient. Okay, it is always more expensive to run a job on large numbers of processes. Okay, I mean, it's more expensive to get a fast car than a slow car, but there's sometimes you care about how fast you get there. Okay, and so you would you would run on large numbers of cores to get fast runtime, a quick overall turnaround, but you always do pay a bit of a premium. Where you get the fastest solution irrespective of efficiency is 96 cores. Okay. What do you think a good core count would be for this application? Well, actually, 24 cores is probably a good idea. It's crazy on Archer to run on fewer than 24 cores because when you request 24, you've got them and you pay for them whether you use them or not. So for this application, because the efficiency drops off so rapidly, because it's a tiny problem. If you looked at it, it's like an 800 by 800 problem. It's a tiny problem, a few megabytes of data. You probably want to run on 24. So this is the kind of thing you do when you get onto a new computer. You take your program, you construct some test example, and you run it, and you see how it behaves, and then make decisions as to what kind of parameters or resources you should request. It's actually interesting to see now. So the reason that the speed up here is poor, only 25% efficient, i.e. only 24 times faster on 96 CPU cores, is because there's this I/O overhead. So if I was to improve the performance of this program, I would need to improve the I/O. But it's interesting to look at how efficient is the calculation part. So if we just exclude the I/O overhead, just use the calculation times to do the same thing, you'll see we get much better figures. That actually the actual speed up is 75 times faster on 96 cores, which is almost 80% efficient. So you can see it's very clear here that the calculation has been well parallelized. The calculation is scaling well, going a lot faster, 75 times faster on 96 CPU cores, running in under 1/10 of a second. But the reason that the overall program is not performing very well is from the I/O. So basically, to get the best out of your thing, you need to know what your priority is. Do you want to get results as fast as possible, or do you want to wait longer? Okay. So when you want to do benchmarking, you need to. It's difficult because you want to run the benchmark lots of times, so it needs to be short, so you can run it lots of times, but it needs to be representative of a real calculation. So you want it to run for 10 to 20 minutes. So the classic thing to do is to say, well, my actual application runs for a molecular dynamics, a quantum mechanics application might run through so many SCF cycles. I can't remember what that stands for. It's an optimization cycle. It might take hundreds of cycles, but you could just benchmark 1 or 2. Okay. Or for example, you might be doing a weather forecast and say, well, normally I'd run 100 time steps, each of 5 minutes, to do a large weather forecast of many hours, but I'll just run 5 time steps. So the benchmarking is an art in coming up with an example, a combination of a program and a data set, which is representative enough of a real calculation to give you useful information, but pared down enough that it runs for a short amount of time. So yeah, so exactly. If you had an image stack of 1,000 processors, you could process 10. If I was benchmarking this program, I would get rid of the I/O, at least the output. Okay. Because I say, well, I know how that's a fixed overhead. There's no point in saying every time I run this program, it takes 5 seconds to do the output. I know that. I'll comment that out and only benchmark the application time. Okay, which of course you wouldn't do with a real program, because the whole point about running a real program is to see the results. But when you're benchmarking, you should check the results are correct. You should always check the results are correct, but you should check the performance. And I don't know if anyone checked the results were correct, but I believe that you should get identical results for this program regardless of how many processors you run it on. So really just the very last section here is just very briefly talking about being a good user. How can I be a responsible user? How can I protect my data? And how can I best large amounts of data off an HPC system? And the biggest difference between using an HPC system and your laptop is you're shared. Okay. You're sharing it with lots of other users, and although the scheduling system is there to give fair share and to run things fairly, it's always possible to do things which, although not illegal, are not very nice things to do. Okay, so for example, if you're a driver, it's not illegal to not slow down and let someone merge in from the left, but or the highway code would say you ought to. Okay, so it's really behaving well, and the main thing is be kind to the login nodes. The login nodes are there for logging in, creating and editing and compiling. It is not there to run computational work. So you can run a quick test for a few minutes, but don't run large jobs on the login node. The login nodes are a shared resource, and if you do that, then you won't inconvenience other users, and eventually someone will complain, and you may get a nasty email from the system admin. Now, often it's not easy to know if you're using lots of resources, because how you see the system is slow. How do you know it's you? It's easy to blame other people, but it might be you that's the problem. So a very useful command in Linux, well, in Windows, is top. So top tells me how much time is being used. So we can see here is user running a Python program, which is using 3 processes, but hopefully that won't run for very long. But I can see that basically this machine is very idle. There's 3 processes using a large amount of CPU, but there's tens of processes, so that's okay. Okay, no problem there. However, I need to be careful that if I run a job, and the biggest mistake people make is to run a parallel job on the compute node. That's actually quite hard to do on Archer, the way Archer is set up. But on other systems, it's actually quite easy to accidentally run a parallel job on a compute node and completely kill the compute node. The other usage here is the memory. Okay. The memory is only a few percent here, which is fine. Okay, there's no problem there. But if you're using up huge amounts of memory, that can kill other users as well. So top is a very, very useful command for just checking either if you're the culprit or if there's somebody else, and everyone's behaving well at the moment there. If there was someone else, you could send an email to the systems team saying, I'm afraid I think that there's something wrong on this particular login node. Okay, so that's something you can do. Login node. So, which of these commands would probably be okay to run on the login node? Well, you shouldn't be running a physics simulation. You can compile, you can create directories. You shouldn't be running a molecular dynamics simulation, but you can unpack stuff. So you shouldn't really be running large computations on the login nodes. There may be times when you have large calculations to do, take up a large amount of memory and a large amount of CPU time, which aren't parallel. How do we square the circle there? Well, many systems and Archers, one of them provide pre and post processing nodes. So they're not login nodes, but they are jobs to run. They are nodes specifically there to run heavyweight, computational or memory demanding jobs which aren't parallel. So there's no point running them on the compute nodes because they're for parallel jobs, but we don't want you to run them on the login nodes because then you're killing other users. You can submit jobs to these serial or pre and post processing nodes. So that's often very useful. This is a simple test in a job script is to not use all the courses. It's very easily done. I mean, it's very easy to make the mistake. Okay, it is worth testing your jobs before you do a scaling, if you do a large run. So basically, test on a small number of processes to check it's doing the right thing before you test on a big number. And we have this dedicated queue at the moment. But if you're a general Archer user, how would you be able to test the job? Well, during the day, or in fact, anytime on Archer, I've put it in the comments. Anytime on Archer, you can run on up to 8 nodes in the short queue. So I would always debug and get my workflows working on small jobs which run on maybe 100 CPU cores, debug it in the short queue before I submit a big job. There's nothing more frustrating than submitting a job, waiting for 3 days for it to run, and then the first line being syntax error at line 1 because you've made a typo in your script. Okay, so it's really important, and that's where the short queue allows you to basically debug things before you go for a big bang run. Okay. Many HPC systems keep backups, but you should really have backups. Data is very difficult to keep a backup, but data is not that important because you can always rerun your job. If you have critical data, you should take copies of it. Tools like ArchSync can automate this, but you should, we do not back up the work file system on Archer, and it is possible that it's resilient against fairly resilient against disk failures, but there's no guarantee that we won't have a catastrophic failure, especially this far into the service when everything on Archer is getting very old. So there are 2 things you should do. You should always make sure that you have a backup plan for your code. Use things like Git or GitLab or GitHub to store things. But also, when you get a project on any HPC system, it will be time limited. Say, right, you've got access to the machine for 1.5 years, for 2 years, and at the end, you're going to have to take the data off. So there's no point generating 10 petabytes of data during a project. If you need to keep that data, you'd have a plan for somewhere to store it. So you do need to think of the whole life cycle of a project when you're looking at a longer term project. Where am I going to take my data? And when you're transferring off large amounts of data, it can be quite difficult to do it. And in fact, there are not necessarily, you may say, well, it's fine, we've got Janet network, we've got 10 gigabit networking, but actually, often it's not the networking which is the bottleneck. The bottleneck can be disk speed. Okay, you might be transferring off huge amounts of data onto a very slow disk locally. Then it doesn't matter how fast the Archer disks are or how efficient the Janet network is, you're going to be limited by the disk speed locally. Metadata performance, this happens when you have to do a large number of small operations. Opening or closing or listing files can take a long time. So that's saying, look, don't transfer a large number of small files, transfer a small number of large files, which can be basically globbing them up using things like tar. Network speed can be the issue, but often it's always the final 100 yards, the final mile. There's no point downloading a large file over the 10 gigabit Janet network if the last 10 yards is done over Wi-Fi to your laptop. That's going to be the limiting factor. The networking in your lab or department might not be very good. So if you're going to have to at some point in the future do a large data transfer, it's worth doing some tests early on with dummy data just to find out what kind of transfer speeds you get and what are the limiting bottlenecks. And the final thing that can limit you are firewalls. Okay, there will be firewall servers which are there to detect and block malicious traffic. They can limit the transfer rate. So it's really important. Don't say there's a 10 gigabit network connection from my university to Archer, so I'll be able to transfer at 10 gigabits, so I don't need to bother transferring the data to the last day of my project. You do need to basically look at this, and there are lots of different ways of transferring data, different tools. And if you have problems, then get in touch with the user support. Say, look, I have large amounts of data to transfer. I've tried doing it with SCP. With ARCHER, it's not fast enough. What can you suggest? And there will be things, tweaks, other tools that we can recommend. So, so yes, the ARCHER does have specific service for data transfer. They're called the DTNs. So if I put up the ARCHER, it's a very good question. Now, whether ARCHER2 will have these, I'm not absolutely sure, but good practice for transferring data. Unfortunately, it's come up as a data transfer node, so I did find it. Oh no, these are on a different system. Sorry. So they are there, but unfortunately, there is a data management guide, and it should. This is really talking about. So there is a system called the RDF, which is a disk system attached to ARCHER, which you can use. So there are data transfer nodes, but I'm failing at the moment to find out where the documentation will be here. I found some documentation, but unfortunately it's a PDF file. Apologies for that. But there are data transfer nodes, and you can use them, and they are there to give you good bandwidth, and also they're not to burn up large amounts of time on the compute nodes, but also on the login nodes. So apologies, I can't find the documentation at the moment. I'll try one more Google. Okay, sorry. So the reason I was talking about, fine. So the data transfer nodes are, sorry, I'm getting confused. There are specific data transfer nodes on the RDF, which is a separate system for disk storage attached to ARCHER. The research Data framework. Oh, I should know what it is. My brain's going woolly after 2 days of teaching. So you would also use the pre and post processing nodes on Archer as well. Can be used for that as well. So the pre and post processing nodes can be used for that as well. So I think Archer 2 may or may not have. I will have some facility for having long running processes like that. Sorry, that wasn't a very good answer. But yes, there are the pre and post processing nodes which you can use for data transfer. And if you actually copy your data across to the RDF, the Research Data Facility, that actually has specific data transfer nodes. It's slightly complicated because the Archer system evolved over time, and the data infrastructure was added on afterwards as a separate cluster. I'm not 100% sure what the setup will be on Archer 2, but there will be a way of doing that. The problem you have with doing long data transfers is that if you do it interactively, you'll have a process on the login node running for a long time, possibly days, and will probably get killed by the system support people. Say that looks a bit dodgy. So you want somewhere which isn't a parallel computer, but that can have long running processes, and these will be these data transfer nodes. But the way they're integrated in Archer is slightly complicated because of the history of the system. So, oops, I've lost my place. So, I mean, that's really the end of the course, slightly over, but the key points for this episode, which I've gone through rather quickly, but it has been quite a long day. Be careful how you use the login system. Your data on the system is your responsibility. The home file system is backed up, but it's a lot of effort and time for the systems people to go and find your data on some backup tape storage. It's really there for disaster recovery. Okay, it's not there for you to say, I accidentally deleted a file yesterday, could you get it back? It's there for disaster recovery. Plan and test large data transfers. Think about converting many logins into a single archive. Don't run stuff on the login node, and if there are on whatever system you're using data transfer nodes, use them. And don't be a bad star. So again, don't be a bad person and run stuff on the login node, which is the thing which really kills people. So that's the end of the session. As I said, it's the first time I've run the entirety of this course, and definitely I've never run it before. The whole course is actually relatively new. We're using the HPC Carpentry framework, at least, to develop the material. So I hope there weren't too many glitches caused with that and with the late transfer from using Cirrus to Archer. All the material will be available for the foreseeable future. This URL here, which is the top level URL, is a snapshot of the course as we ran it just now. This is the URL which is linked in from the main course page. This will just stay up there forever. The videos, well, for years anyway. The videos take a little while to process, but they will be available shortly. I know that Luciana wanted to say something at the end. She wanted to announce, just make people aware of something that was just going on. But I know that she had problems with her account, so in the end wasn't able to attend the whole course. So unless Luciana is on, I'll just say it. Luciana wanted to make you aware of, I don't know exactly what message she had, but she wanted to make you aware of the HPC certification forum, which I'm going to type wrong here, which is a kind of community effort. I've spelled that wrong, but if you Google that, it's a community effort to try and come up with a bunch of training material. Well, EPC is involved with it, mainly through my colleague Veronica Fillinger, who's done work on this, to come up with a core set of competencies which people can learn, and also a way of certifying that, so you can do some tests or whatever assessments online and say, look, I have qualified to this level in these areas of HPC. It's just something worth keeping an eye on. So I've put that URL up there. I think that's what Luciana wanted to talk about, but I'll mention it here, and it's going to be on the video here because that's where it is. So that's something she wanted to mention, which you might be interested. I don't know how much training material they have. So Juan, thanks Juan, that's very useful. So that's a webinar at the end of July under the ARCHER2 banner. So that's very useful. So that's an ongoing effort to try and provide a bit more structure and also certification for having completed various training. So are there any final questions? These accounts will be available, I believe, until the end of July. So you'll have access. So if you want to carry on practicing running jobs, you're able to do that till the end of July, in which case they'll become deactivated. Okay, so I hope, I know a few people stayed to the bitter end. It's been a bit tough. I don't know if I previously considered running this as 2 separate days to break it up a bit, a Monday on 2 different weeks, but I did that before for another course and somebody said that they'd prefer it to be all in one. I know it's horses for courses and it's quite a lot of, apologies for the issues we had at the start with access to Archer. In future courses that will be more streamlined. Unfortunately, this course came right on the tailcoat of having all these issues with the Archer security and these SSH keys and uploading via safe, and it's all very complicated, and we'll get round to streamlining that a bit in the future. But I think we mostly managed to get there, which was good. I will say that the kind of free and easy, so that's the error you get when you will be running in /home. Remember, so for you, that will be, I can basically, what do I say? Yeah, so yeah, so you /work. I don't know what your username. I should know what your username is, but if I give me a second, I'm just looking up. Yeah. So you'll need to do that in your on the login node. So you'll need to work, because that'll propagate automatically to your batch job, because in the batch job you'll have a CD $PBSO work there which will go there. But you need to. So actually, when I log into Archer, the first thing I do is CD to my /work directory, because it's much easier. It is very confusing on Archer. You can do almost everything from /home except, well, write jobs to that file system from the compute nodes. So it is quite confusing. Does that answer your question? It's a very common error. I did it this morning. I was testing the jobs out this morning and they failed, and I thought, oh no, I've made a mistake. What have I done? I realized I was running from /home. So we all do it. It's very, and you don't, yeah, does that answer your question? But I did it this morning. It happens all the time. Yeah, fine. So you should be able to run from /work. So, well, I'll show you. I just checked that I understand what you mean. What you should get is, so something weird is happening. Okay, so I will share. Okay, so if I'm in this, okay, what I get is as output, I get sharpen.pgm, which is my output file, but I should get a .o file, the PBS output. And that involves the standard output, which is printed to the screen. Is that what you were, do you not get that file? So, you know, that will say image sharpening running on one processor. calculation time, and overall run time. So what I did when I had to get what I did this morning is I created an ARCHER called Sharpen. So the test results I just showed you were created with this PBS script. Okay. Oh no. Maybe not. I can't remember where I ran this morning. I wanted to show you something, but I may have overwritten what I did actually. Oh no, it was in PBS. Sorry. Okay. So I ran this morning, and the script I ran was called, I guess it was called runsharpen.pbs. I hope. No, it was probably called Sharpen Scale. Okay. This morning I meant before when I only generated those test results this morning. So this is what I ran this morning. Okay. So this is where the scaling data I showed you for reference data I just generated this morning doing this. Okay. And so I ran on these numbers, and then the output file was sharpenscale.07010365, and it has all the results in there. It's a bit verbose, so I just did grep seconds on that file. That's where I got all the results and cut and paste them into the spreadsheet. So Matt, did you get a .o file which should have all the output? So my screen prints, it explicitly writes the answer, yeah. So so that would normally that is what would normally have been printed to the screen. So my program explicitly opens and writes an output file called sharpen.pgm using fopen, fwrite, fclose from a program, but it also prints to the screen the debug data, how long it took, what it's doing, hello, here I am. And of course, in a batch job, that can't appear on the screen, so it gets squirreled away in these .o files, which are quite easy to miss. So does that have the right data in it? Just check there wasn't a problem. Yeah, okay, good. So it's a matter of, that's good. So it should have, so all the screen output from all the separate runs will be there. Good, okay. So are there any other questions? If not, I'd like to remind you again of the get reminders about this, but it is very useful for us to fill in the feedback form. I'll show you that actually live, just to show you how it looks. It's not scary at all. It is very useful. I'm sharing the wrong screen here. I'm getting a bit tired. Yeah, so if I basically, if you go to that, you will get this in an email. So so it's automatically selected. The name is optional, but we just like you to fill in, give your opinion on the course. And we do take feedback seriously. We review it at a weekly meeting, which would actually normally be today, but we're skipping it this week because we're giving a training. But we meet every week to review training, to review the feedback and take it on board. Good feedback is great because it makes us feel good about ourselves, and we can tell EPCC how wonderful we are. But also, you know, poor feedback, as in critical feedback, is also very important. We do take what people say seriously and try and improve the course. The default is to fill the form in anonymously. However, sometimes people say things which you know, they'd like more information and such like. So you are welcome to put your name in there, but the default is to fill it in anonymously. Sometimes people find it useful to put their name in there because they're asking for specific, you know, oh, it'll be nice to know about this, or maybe you could get back to me, I had some ideas. That's up to you. But, you know, it's there, it's default anonymous, so you can give your honest opinion on what you thought of the course. And as I said, we review the results, myself and, well, mainly Juan now, and then we look at it and then we feed it back into the process to try and improve the courses. And we're particularly interested at this time because it's, you know, we're moving to online training. You know, there are things which I would like to do. It's fairly new to everybody, and if there are suggestions, that would be great. There are things I'd like to do. I would really like to be able to have your avatars and not see you all just as heads and shoulders. I tested that out beforehand and it worked, but clearly that I must have had special privileges I wasn't aware of. So I was able to change my avatar, logged in as a guest, but you clearly aren't. So things like that we need to streamline. But I think in general, the technology's gone reasonably well. So if that's everything, I'll shut up shop today. We're finishing just about on time. And I hope you enjoyed that, and I hope you found it useful and you learned something useful. And I said, if you want to revise the material or refer to it in the future, it will be online, and there will be videos which might be useful if you wanted to follow the whole course. The one thing I would like to say, one thing I wanted to mention is there's also a thing which is also running called the we run it's a MOOC, a massively open online course called, it's currently running, it's on the FutureLearn platform, which is the Open University's online arm, and we developed it as part of PRACE along with collaborators in the Netherlands, Surf Sarah, and the course is running at the moment. It's completely conceptual. There is no there's no programming involved in it, but it might be something you might be useful to recommend to colleagues. Previously, there's been a lot of involvement from us in helping. It's currently running in an unfacilitated mode, which means that the course is running. It's not very hands-on, but the material is there. It's free to join up. They do try and get you money to do various online tests, but you can do the whole course for free, and it's in its third week. But you can join now and still follow the course. So that's something else I meant to mention. But I'll sign off for now. It's nice to meet you all, at least virtually, and chat to you. And yeah, keep an eye on the ARCHER2 training pages, because there will be upcoming courses, you know, possibly following on from this, courses on how to use ARCHER2 in particular, courses if you do want to learn about programming, courses teaching you programming, teaching you how to parallel program, if that's something you want to learn about in the future. Okay.